7:41 by my clock, so we'll go ahead and get started here. Welcome everybody to Don't Forget Your Infrastructure, joint presentation by Tim Chase of Lacework and me, Greg Sternberg, security architect here at EVOTEK. Sure all of you have heard of the various headlines and all this sort of stuff. And the focus has been on supply chain and all that sort of stuff, but we're going to take a slightly different point of view here. So with that, I'll turn it over to Tim for his bio, and we'll just get this started.
All right, thanks, Greg. Appreciate it. So my name is Tim Chase. I am a field CTO at Lacework. So just kind of a quick, brief bio. Been doing cloud and application security now for about 20 years. The last few have been focusing really on cloud and how that intersects with DevOps and DevSecOps. And so done various conferences and have some LinkedIn training, all around that particular topic. Greg?
And my bio basically boils down to security architect at EVOTEK. I've done just about everything involving computers and programming at some point in my history here. Do a number of various things in my off time, volunteer in some boards, teaching, mentoring, all that sort of stuff. But with that, we can go on to the next slide here. And well, I have 2021 here, but 2020 and 2019 probably would fit just as well. We've all heard about the failed application security issues. We all know about Log4j. There's a number of other ones there. And we all talk about supply chain hardening, secure code, code scanning, developer awareness training, all that sort of stuff. And, yes, that's all very important. That's all very good, very needed, important things to focus on. But there's a risk that when you focus on those pieces, you could miss another fundamental part of your architecture as a whole. And that's sort of what we're here to talk about. Tim?
Yeah, absolutely. So, application security is important, but it's just one part. And I think, sometimes when you talk application security amongst peers or when you're really thinking about it and breaking it down, you really focus on the app and you focus on your libraries and the secure code and all of that. But attackers are still getting in via the infrastructure because as we move toward the cloud and our architectures become more complex and they're not totally in your control anymore, there are a lot of things that we have to really think about. And that's where we need to say, the AppSec stuff is still super important, but we need to take a little bit of time and make sure that our infrastructure is secure. And this is kind of a sample diagram that I found on Lucidchart's website, but I think it really highlights what a typical cloud diagram can look like. I'm like I said, I've been doing this for a while now, 20 years, and back when I first started in security, diagrams didn't look like this. There were a lot of firewalls, switches. IDS and IPS, they were there. But, then there were just a bunch of servers and you had these things called DMZs where, anything touching the internet was going to be right here. And then everything else was in their little segment. But that looks nothing like what a modern architecture looks like today. And so I think it's, worth a little bit of time to kind of dissect this and talk about the problems. And how we can really look at it a little bit differently to fix them. And so if you look into this diagram here, you can see that we've got, the people connecting up here that come through the cloud DNS. You may have your CDNs for any of your content that you're, that you want to be quick and on the edge. And then you have your load balancers, web servers, app servers, and then, maybe some paths, like some databases of servers or something like that, right? So we need to talk about what are the different steps that you can use to help secure some of these in a different way, right? You really have to shift kind of your mind on how you build out an architecture when you start going cloud native.
Yeah, and one other thing I'll kind of toss on here is, and this is a common problem in architecture, but you look at a diagram like this and it looks simple. You got a couple boxes, you got a couple lines, everything looks clean, straightforward, but it hides a lot of complexity behind it. You talk about a load balancer. Well, a load balancer is sometimes more than one load balancer. It might be in AWS, it might be in Cloudflare that's spread out over AWS and Azure. You have balancing in there. You have or a CDN delivery. I mean, it gets really complex. So that's the other thing about these that's perhaps, well, actually, it is different from when I first started, is just the sheer level of complexity that's hidden behind such a simple diagram.
Oh yeah, absolutely. There are a lot, and it's not always easy to just take a peek in and see where your holes are, right? Because you're talking about, and we'll talk a little bit more about this, but multiple accounts, multiple cloud providers, so on and so forth, right? And then also, I wanted to talk just for a second about containers as well. So a lot of times, when you're talking about, and maybe not so much anymore, but I can tell you that in my experience with containers, people would think, hey, we'll just containerize something. You don't have to worry about the AppSec anymore or the infrastructure, right? It's a container. And so all of that is handled for you. And you don't, they're so ephemeral, and they're up and they're down, and you don't have to worry about it as much. But you can see here, there are several different parts to this container that will break down at a later time. So you still have to really worry about your infrastructure, even in a container world.
And the other thing about containers, which actually was kind of touched on in a previous session, containers are up and down. They're here and there. So that sounds like, okay, great. If there's any problem, it'll immediately be thrown out with the next, release or update or refresh or restart. Well, the problem with that is something comes in, and we're talking machine speeds here. So something that's up for 2 or 3 seconds from a human standpoint is like hours, days, and weeks to a computer. So in that small time frame, it can break in, do its malicious stuff, and then you destroy the container. Where's your traceability? So this isn't just a simple, it's in a container, therefore it's safe. Doesn't quite work that way.
100%. And you can see here, I've got it nice and broken down. But we'll talk a little bit more about that in a second. So let's talk about securing the infrastructure, right? And so just for simplicity's sake, I know you could probably maybe add some more or break these down even more, but I think we just kind of broke down when you're looking at your cloud infrastructure, what are the different areas that you can focus on? And so kind of divided it into, network, the servers that could be, your servers talking externally to the internet or to users. It could be server to server communication inside. But how do you secure your cloud network? And the next one is identity and access management. So, identity is a huge problem, as you federate inside of these different cloud environments, and a complexity inside of a cloud that many people don't realize is that identity just doesn't comprise users, right? It's just not me and Greg and whoever else. But identity inside of a cloud provider can be resources as well, right? So inside of AWS, you can have policies and roles that you assign and attach to resources like a compute instance, right? And so that's another complexity. So how do you manage all of that to make sure that you don't over provision, and make sure that when somebody leaves your organization, their permissions are revoked? I mean, I did another session earlier today where we gave the example of there was a major infrastructure provider that had an AWS presence, and one of their people left. They didn't remove his access from AWS, and then a few months later, that guy was still connecting in to their cloud environment in AWS. He deployed some of his own GCP code maliciously, and it deleted about 450 compute instances, and brought their service down for about 2 weeks, and cost them about $1.5 million, right? And he got jail time, fines, all sorts of things, right? So malicious insiders are a big deal. And so, how do you secure your IAM? Workload security. This could be your either like EC2 instances that you go into and that you run yourself, or it could also be containers right here. So anything else you want to add before we go on there? Securing the network?
No, I think you hit all the salient points.
Cool. So, kind of breaking it down even more, there's different aspects. This is an AWS example, but any of the cloud providers are really similar. The terminology may differ a little bit, but they're similar in their nature, right? So you'll, like I mentioned, you'll have your external communications here, right? So how do you secure this gateway that talks outside, or how do you secure, the firewalls or anything that may be talking directly to the internet? How do you secure the server to server communication? Because one of the advantages of cloud is that it makes it easy to microsegment, right? So you can make sure that in the case of server A, it should only be talking to server B. Back in the data center days, that was really hard to do, to really kind of microsegment who was talking to whom. And so, locking down the server to server communication, how do you make sure that you understand what is supposed to be talking to what, and then when something deviates outside the norm, you're alerted. And then finally, VPC. So you have these little virtual private clouds here, right? So this is kind of a way to segment your networks in the cloud, and there are different ways to do it. It could be by business unit, dev, test, production. Just that's a whole nother it's a whole other session to talk about that. But, how do you secure that and lock those down from a firewall perspective? Because you can lock the VPC down to make sure that your servers can't do anything that you don't want them to do.
Yep, and as alluded to earlier, there's a lot of complexity hidden there, and even just the simple things like, least privilege. Okay, I'm going to prevent server X and Y from accessing. Well, is it you want to prevent X and Y, or is it you really want to allow P and Q? Again, these sort of decisions have to be talked through in a business context.
Absolutely. So, we talked about it's hard, right? So, but what are some things that you can do to secure your network in the cloud? So, one is that I'm pushing, and we'll have a shift left slide later, but use infrastructure as code to ensure consistency, right? So if you're going to the cloud and you're going there and you're creating everything manually, every time you do something manually, you run the risk of doing something different and not having that consistency. So use infrastructure as code so that you can have everything just like you would any other code. You can have it peer reviewed, you can have it checked in, you can have it keep track of the changes over time, right? And so use like a Terraform, CloudFormation, something along those lines to make sure that your infrastructure is deployed that way. Use some of the cloud native security monitoring. So, for AWS, GuardDuty, GCP's got Command Center, Azure has Security Center, but use some of the native tools, right? They're there for your use, and sometimes there's a charge, sometimes there's not. It just depends on how you use them and which tools, but they know their cloud provider, right? And so GuardDuty is able to look and ingest a lot of those CloudTrail logs and give you some information on what's going on your cloud accounts. And so start by using some of those tools, and then eventually potentially look at some third-party tools to help. The cloud native tools are a good start, but when you start getting more complex in your cloud journey, you'll probably have multiple accounts, multiple cloud providers. As I talk to clients, the larger clients, it's very rare that they have one cloud provider. Many use one cloud provider for compute, another one for their data services like BigQuery, things like that. So depending on what they're doing, they may be in multiple cloud providers, and that's where it becomes a little bit more difficult to scale from a security perspective. So consider the use of third-party tools to help you look for those open ports, those in those open S3 buckets that you don't notice.
Yeah, and another advantage to third-party tools is, especially if your business is, lives and dies by the cloud. If you're only in one cloud, that cloud collapses, like a certain three-letter acronym cloud, which we won't mention here right now, you're in deep trouble. So being able to shift your information, your processes, your business from one cloud to the other using some of these third-party tools helps with the disaster recovery piece of it too.
Yeah, absolutely. Moving on to IAM, right? So this is kind of identity and access management. So controlling who can do what and what can do what. So like I mentioned, inside of the cloud, it's more complicated than I think than an on-prem infrastructure, because you give permissions to resources and objects to be able to perform actions on other objects, right? And so it's not as straightforward. And then to add on top of that, usually you've got, and Greg, you can correct me if I'm wrong, but usually it's 4 parts here that go along with IAM, right? So you've got your user, the role, the policy, and the permissions, right? And those are kind of, in a specific role, you typically will have your permissions of exactly what they can do. You comprise those of policies. So one policy will have multiple permissions. You take those policies and then you can assign them to multiple roles, and then from there you assign them to users or to resources, right? So that makes it a little bit complicated, right? And so one of the things that you have to think about and to do is make sure that you're not over permissioning resources. Number one, give people only what they need to do their job, and then also you need to make sure that how do you track if this is my last day at Lacework unexpectedly, what happens to my cloud account? You need to be able to track those movers and joiners, right?
Yeah, the other thing I'll add to that, and anyone who knows my interest in software understands this next comment. A lot of times when we think about IAM, we're thinking about a user, a you, a me, somebody like that. IAM is extremely vital in API security, because your APIs are effectively a robotic user. You have to know who they are. They have to have a role. They have to have policy. They have to have permission. So all of that is just as applicable at the code level as at the user level.
Absolutely. So kind of the how, right? So how do you do it? So you need a tool. You can do it manually, but you really need a tool to look at things like to make sure that you've got your policy set up like MFA. I know that may sound silly, but it's still not uncommon, to not have MFA set up. So the last time I set up an account in AWS, I believe it was still default not to have MFA for your account. Like your user actually has to go back in there and re-enable MFA, right, by default. So, which is still interesting to me. But making sure that you have things like MFA turned on, and the native tools like GuardDuty will alert you on things like this. Abnormal login, abnormal user behavior, right? So, what if I always use AWS? I'm sitting here typing and I'm always in US East. And then all of a sudden I'm connecting from London, right? An hour later, impossible travel, right? So you need to have tools that can help you understand how to do that. And then abnormal user behavior. The best example here is by looking at resources. So if I've got a compute, if I have a compute instance, an EC2 instance that day in and day out, it talks to RDS, like that's its job. And because it's looking at a database server, it's an app server that's talking to the database server. That's what it does every day. But then all of a sudden it starts communicating via SSH to another server. Like that's abnormal user behavior, and you need to have you need to watch out for that, right? And you need to have a tool in place that can help you to do that, to watch out for it. So a couple of things here, and not necessarily one tool will fit all, but I did slip something in here, Greg. I think I reminded a couple of days ago. So just-in-time provisioning, that was something I wanted to mention here. Like you can use federation. So if you guys are using like Active Directory or something like that, you can hook those into AWS to make sure that you can control those accounts and tie that into your overall identity strategy. And just-in-time provisioning gives those users, you can use something like like if they need access to an S3 bucket or something for only a certain time period, these cloud providers have a way to give them a secure session ID that would only last a finite amount of time before it expires, right? So using a combination of those two things with identity will help. And like I said, you can use the cloud native here to start. The security center, command center, GuardDuty, those things do analyze for things like MFA and logins. Where you really want to start leaning toward a third-party tool to help is with sometimes with your abnormal user behavior. That's more pattern based. Tools like guard duty and things like that, they're good, but they're a little bit more rule centric. And so sometimes you need a third party that is a little bit more behavioral based, that can really look at the overall pattern of what's going on in your entire cloud environment to look for those truly abnormal behaviors.
Yep, and sort of as I touched on the previous screen, this applies to API calls too.
Mm-hmm.
If your API call is always calling this particular thing with this particular information, and then all of a sudden it's calling with, unreasonable parameters, maybe that's something to pay attention to. Again, users and APIs are pretty much interchangeable at this level.
That's true. No, that's a valid point. One I've made in my training before, and I forgot to put on here, but absolutely, especially in the DevOps world, right? The key in DevOps is API driven, to get hands off the mouse.
Yep. Yeah, and to be honest, the API that you had there last week may not be the API there this week, just from that whole DevOps thing where they release releases as fast as they possibly can. So you sort of have to keep track of all this.
Absolutely. Workload security. So how do you secure those workloads, right? So I would say for the most part, like if you're running servers in the cloud, like an EC2 instance, you'll use your typical workload security, right? You can't forget to secure it. Just because it's in the cloud doesn't mean that it doesn't have to be secured. So you'll have your normal AD or EDR type of scenarios that you have on the servers to monitor and protect against viruses and strange user behavior. So I think that doesn't really change. The one thing that I would say that to me still changes is you do still want something that can analyze the pattern of what's going on. So we want to understand what is running on it and who it's talking to. So I think that having something, a tool on the servers that can kind of still see those usage patterns, I think is still valuable from a workload perspective. And then container security. So one of the things that I didn't break it down on the other slide, but when you look at this, you've got a lot of different pieces here, right? So you've got this is kind of an example of a container. It's an easy example, but you've got the infrastructure that the host server runs on. You have the host OS. You have Docker or Kubernetes or something that's running on top of the host to manage your containers. And then you have all of your containers, which are each running their own apps and their own libraries, right? So when you look at this holistically, you've got several different parts that you have to secure. So it's not just because, like we said, just because you're running a container doesn't mean that it's secure. So you've still got to, the cloud provider typically handles this part here, right? So it's a little bit of a bleed in to here sometimes with some of the configuration that you can control on the cloud provider. But for the most part, the cloud provider is going to handle this. But one of the things, if you're running your own, some people like to run their own container hosts. They don't, use ECS, EKS. They like to run their own hosts, and that's fine. And if you do that, you really have to worry about securing this part too, right? You got to make sure there's something called container escape, just similar to like VM escape, if you're familiar with that, where there could be a vulnerability here in Docker that allows some exploit in this container to do container hops and go across containers and get data that maybe you don't want them to get in container C here. So you've got to secure the overall host, right? If that applies, you've got to secure the app. And then you got to secure, any of the hardware actually running any of the containers themselves, like the OS level. So, but one of the things that I will say that's different from typical infrastructure security here is you need to keep the footprint small. So most typical antivirus EDR solutions, they don't work. You need to look for something that is container specific or that works well on containers, because normally the object of a container, you're not normally going to run like MongoDB as a container per se, or like Oracle as a container per se. Like you don't, usually containers will be sort of smaller and they, microservice based type things. And so you need something that will keep the footprint small, not cause a lot of overhead. And so you need, that's the biggest part here that I would say. But you still need to understand what is running and who it's talking to, right? So that's that's something that needs to happen at the container level. You need to understand, container A always talks to container B, but never talks to container C. And then if one day A starts talking to C, you have a problem, right?
Yep.
And one thing I did forget to mention, and I apologize, kind of around container security, or definitely around your workloads, we had a comment that was a good point that, monitoring configuration drift, is essential. So being able to understand, and this is, to some extent, you want to be able to monitor configuration drift inside of your production environment. And what I mean by that is, you need to understand what changed on your server and when. A good example of that would be ports changing. Like if your server never has port 22 open at all, and then one day it does, like you want to be able to monitor that and understand when something changed and go back and see who changed it. The same would be applicable to container security here. Greg, I've been talking, so please take a turn.
It's perfectly fine. I was actually going to talk about the configuration side.
Okay.
Because that is actually something that I have seen done in red team attacks is, they may not be able to breach the container, or the libs might all be up to date, or Docker or whatever. But if they can go in there and they can change the configuration for something as simple as, the least privilege. Okay, I go in and I'm only allowed to talk to 5 IP addresses. Well, I'm going to add on my 6th one there. That means that the container goes away. All trace of your changing it goes away. Next time that container comes up, guess what? It's open to the internet. So yeah, that configuration needs to be monitored and tracked.
Absolutely, it's a great point. So you need a tool or something, some mechanism to do that. And you can do that, and we'll talk about, if we just kind of move on, you can do that in a shift left sort of manner as well, right? And so let's talk about that a little bit, because I know we've got it looks like about 8 minutes left. If I did my math right, maybe I did, maybe I didn't. So, production monitoring is good, but shifting left is better. And so what that means is, monitoring in production is a must have, but if you can keep it from ever getting to production, that's really the where you want to live, right? You really got to have it all, right? So, taking a look at kind of the log4j stuff that we're all in the middle of right now, it's good to know both. Sometimes you'll have those 0 days that you have to monitor in production. Like you can't catch everything on the shift left side of things because you don't know that they exist yet. Like we didn't know that there was a vulnerability in the log4j until we knew it, right? And so that's why you have to have your production monitoring in place to look for those 0 days being exploited. But it's also important when you know of vulnerabilities, when they're out there, they already have CVEs assigned to them, like looking as far left as you can, to all the way over to when a developer builds the Terraform script, knowing then can save you a lot of time, money, and risk, right? And so you really need to look to when you're modernizing your infrastructure, treat it just like code, and put it in your pipelines just like your development code, right? With infrastructure as code, like a CloudFormation or a Terraform.
Yep. There are programs out there that do scanning of Terraform and those other third-party scenarios, so that can just be nicely tied into your whole DevOps pipeline.
Yes, and speaking of which, so there's shifting left could look something like this. So you got the Lacework logo and the soluble logo here, but you've got your pipeline could look something like this, right? So you've got your code over here, which would include your infrastructure as code. Right, so you scan this here, and then you can integrate it into your Jenkins pipeline or whatever pipeline you happen to be using to fail it. Right, so you can set those policies to say, hey, if there's anything critical in my infrastructure's code, don't let it go to the next step. Right, and the same thing here, with your vulnerabilities of your containers. Right, so integrate that into the pipeline so that you don't have any containers that make it further up into production that have known vulnerabilities. And then you have to have this continuous runtime protection on this side as well, right? So all of this kind of works together. It's called shifting left, which is true because you want to shift everything as far possible as you can to give developers that control so that they can fix it early on. But it's really still kind of like shift everywhere, right? It's important to have security in this entire process because it's all important. Shift loop, exactly, Matt. Like it's a continuous feedback loop. Yep. Is the what I like to talk about. You're exactly right. And yep, so that's good stuff. And then just kind of this one slider here about Lacework. So we can secure, we can do posture and compliance. So looking for those open S3 buckets, looking for those ports that are open to the world. We can, if you've moved to the cloud and you need to be able to do compliance like HIPAA, ISO, we can help with that with some reports that you can provide to auditors to save you time and money. Vulnerability management with those libraries, the code libraries, the server libraries like the kernel versions, and then threat detection monitoring for those knowns and unknown bads like crypto mining or inside threats, and do it across multiple clouds, right? So that's the key is when you get to that point where you're on multiple clouds with multiple accounts, it gets unwieldy to do it on your own, and that's where someone like us can help. So.
No, I completely agree with the unwieldy part. I've had some experiences with that. And yeah, one is bad enough. Two, I would say, is exponentially worse.
Yeah. Yeah, I can remember early on when I first started doing this, I ran cloud security for Nielsen, the ratings folks, for years. And we started with no cloud, and then they kept adding accounts and adding accounts and adding accounts. And I'm like, oh, God, okay, here we go. And that was early on when the cloud security tool market was very immature, and we got on the evident.io bandwagon. If that ages me at all, they got acquired a long time ago.
Yep.
But that's what I have. So I do appreciate the time. Happy to take any questions, which look like we've got one here.
Yep.
Yeah. So Matt asked, what are some of the epiphanies clients have experienced in the initial stages of Lacework deployment implementation? We had several, right? And so there are some good use cases. The initial stages, I would say, one is how easy it is, right? So I've worked with multiple cloud security vendors, and the reason I'm here, and I think many people would say it, is how easy it is to get Lacework set up. They've within an hour or two, you can have our agent deployed across all of your environments and start getting real actionable data within several hours, because we're behavioral based, so it takes a little bit of time to understand the behavioral behavior of what you're doing. And the other thing that I'll say, just to kind of give a realistic example here of Log4j recently, we do a lot of security assessments right now. If anybody wants to just kind of understand what problems they may be having in their cloud, that's a no cost kind of security assessment with a threat intel team. But we've done a few, and I think people were surprised at how quickly we could deploy us and get the feedback to know how pervasive Log4j was. Like, they thought they had an understanding of Log4j in their environment. They deployed us, and then all of a sudden, like, it exploded, and they had an even better understanding of that, right? So I think both of those things are some initial, just kind of the initial things that they found with us.
Yeah, and I got a question here from the other Matt S. in our organization. Let's see, how would I advise? That's a very good question. Well, to begin with, I always like proof of concepts. You don't go into a multi-cloud environment with hundreds of applications and turn it on across the board. I mean, assuming your infrastructure can even handle all the information, it's just going to overload. Pick a couple of applications, maybe just a single cloud, maybe one application that does multi-cloud. And Tim probably will have some more suggestions there, but that gives you a narrower subset. And then you can sort of focus on, okay, what came up with this? What's the important things to take out of that? Then you feed that back into your process, and then you expand it a little bit more. As I lose my voice, then you expand it a little bit more. But this concept of we're going to come in, we're going to turn it on for everything and all the time, and just overwhelm our SOC analysts, that's never my recommendation, to be honest. So start small and make a plan for, we're going to expand it. The information that comes out, we're going to do this with it, which may even change the plans for implementation.
Yep. And I'll add on that just a little bit. One of the things that I preach on when I talk about DevSecOps and DevOps, when I'm looking at a tool like this, is talk to them about how these people currently work. So your SREs, your developers, like, what tool do they currently work in, and work with them. So if they're using GitHub to store their code, we'll integrate your tool with GitHub. If they get their notifications for pipeline fails inside of Slack, integrate the tool with Slack. Like, don't force the other teams to conform to the way that you want security to work. Like, work to conform your security practice into the other people's ways of working, right? Slack, Jira, what have you, right? Like, that's the way to get security to succeed. You don't want to be the roadblock. You want to integrate.
Yeah, this definitely seems to be my day for cliches, because I'm going to go with another one here, and that's we don't want to be known as the office of no.
Mm-hmm.
If you can, like you said, if you fit in with the process that the developers are currently using, they're far more likely to say yes than ignore it, put up roadblocks or whatever.
Yes, 100%. Any other questions? I'm always available after the fact. I'm tim.chase@lacework.net. So I'm always happy to connect on LinkedIn or via email to anyone. So, all right. Thanks everybody for coming. It's good conversation, Greg. I appreciate it.
Thank you very much, and I'm always interested to know more about Laceworks.